All right, now here's the protocol for vegetation sampling. The list of materials you'll need include the meter squared PVC quadrat, the cardboard percent cover reference squares, there'll be 3 of these, your data sheet, a camera or a phone camera, a small whiteboard, and dry erase marker. Big picture, here's our checklist for our vegetation sampling. At each plot, we'll conduct an assessment for species richness and then percent cover by cover type. So we'll be looking at bare ground, rhizomatous grass, bunch grass, forbs, shrubs, and litter. We'll also identify the dominant species in each plot and estimate the cover of that species. So before we dive into our sampling, we want to take a picture of the plot so we can use it to look at vegetation cover that way in the future and just to be able to double check our notes. So you'll use the whiteboard to write down kind of where we are. So our site is Cedar Creek. Today's date. And then the transect number and the plot number and your name. Then what we'll do is take a picture of the plot with the whiteboard right next to it for our records. So you can use a regular camera or a phone camera. And you want to take the picture from about your chest, looking out down on the plot. So check it, make sure you've got a good view, and then you're good to go. The first thing that we'll do with vegetation is just kind of look at the plot and see what we're working with. So we can see we've got a lot of litter from last year. And the first metric that we'll do is species richness, so the number of unique species. And we don't need to identify the actual species, but we want to know how many different species are present, so a morphospecies approach. So we'll look at the plot and work through in a systematic way from one side to the other to identify different species. Here we've got a fair amount of litter from last year, so we want to make sure that we're looking through the litter to see what we find. Starting here, got one species of grass here, another different species here. So we're systematically working across the plot. Make sure we don't miss anything. We have a forb here, so that's 3. Oops. We have a different forb here, 4. Another forb, 5. It's right on the inside of that plot. That's the same as before.
And another thing to keep in mind is that when there are few species, people tend to overestimate slightly how many species are in the plot, and when there are many, they tend to underestimate a little bit how many species are in the plot.
So something to keep in mind as we're going through this. So we're at 5 right now, right?
Mm-hmm.
Nothing new yet.
And we won't count litter from trees that blew in, other species from last year.
There's a forb. Maybe forb 6.
Are those the same or different?
I think these two are the same.
Yeah.
So we're still at 6. This is a new one though. So 7. So we went 8. There's that same one we just saw. So we're looking at 8 species for our species richness. All right, so now we're going to look at percent cover. And so the idea here is to understand the relative distribution of different functional types. So what we're focusing on here is bare ground, rhizomatous grass, bunch grass, forbs, shrubs, and then litter or any other notable cover. So the first thing to do is to, at the very beginning of a day, work with your partner to do some plots on your own and calibrate with each other. So for the whole sampling, we'll have one person responsible for all of the cover estimates, and that's to minimize variation. But it's been shown that when that person works with someone else and kind of calibrates by both working on their estimates individually, that can kind of normalize someone's estimates. So Forrest and I will each walk through, and for each of those cover types, we will independently look through and try to estimate what percentage of the plot is covered by that cover type. So we'll do that one at a time, write down our estimates, and then compare notes and talk about, okay, why did I have X percent while Forrest had Y percent? And then from that, we'll do that at 2, maybe 3 plots, practice plots, and then you'll be ready and a little bit more calibrated. And in this case, then I'll do the percent cover for the rest of the transect. So when we're thinking about percent cover, there can be some helpful tools for estimating. So you'll have some references. So we have a 1% reference. What's cut out is a 5% and 10%. So these can just be helpful to calibrate your eye to what these percentages actually look like in the plot. So one approach that can be helpful is to say build up by looking at small ones and building up from there. In some cases, a cover might be so pervasive that it's actually easy to subtract what's not covered. But you can use these to just sort of help train your eye and say, okay, what does 10% look like, 5%, 1%, so on.
One issue that we commonly come across is overlapping vegetation. And to make the cover estimates closely correlated with biomass, we want to account for the fact that there can be multiple layers of leaves stacked on top of one another. And so what I often do is try to estimate cover for one of these functional groups, and then imagine that those plants are removed from the plot, and then estimate cover for what's remaining for the other functional groups, and continue on, so on and so forth. And so the total amount of cover can add up, and often does add up to more than 100%. And that's not a problem. That actually helps these estimates be more closely aligned with biomass estimates.
Another thing that we'll be doing is we're going to be using cover classes for our estimates. So instead of estimating to the percentage point, we're going to be using these classes called Daubenmeier classes. And the idea behind that is it's shown that it can be very hard to differentiate, say, 50 and 51%. or 70% and 71%. But at the small end and the high end, it can be easier to tell apart those differences. So the classes, which you'll have noted, there's 6 of them. The first is 0 to 5%. And then we have 5 to 25%, 25% to 50%, 50 to 75, 75 to 95, and 95 to 100. So you'll be recording the class, that percentile, not the specific unit percents. Right, so starting off, we can kind of high level observe a few things about this plot. So we don't have any shrubs. There's very little bare ground, and we have a lot of litter from last year. We also have just a couple individual forbs. So for our shrubs, we can say that first class, 0%, no shrubs. For our bare ground, similarly, we're totally covered. And then we can start, we've got little individuals of forbs here. So, in my mind, what might work well is trying to imagine, get out my reference here, trying to imagine these individual forbs that we have across the plot. So for me, what works well is trying to put them together and then think about if they were all clumped together, what percent would they be? And then I'll use the 1% as a reference point. So if I can put, there's a couple, Forrest, can you point to those, these, if I can put them all together, I'm looking at about 1%. So that's going to be in that first class. So that'll be that first class. Now, in this particular case, for the grasses, given the stage of development, it can be really hard to tell apart the rhizomatous grasses and the bunch grasses. And that might be something that you find out in the field. We can see here, this looks like a good example of a bunch grass from last year, but hard to tell some of these new growth. So one approach there is to just first of all estimate the cover of the grasses. So we want to know how much grass cover there is. But then and make a note if it's difficult to tell the difference between the rhizomatous and the bunch grasses. And if you can tell, then try to separate them out. But if not, good to at least know percent grasses.
Right.
Okay, so let's recap the strategies for estimating cover. We can bundle, where we imagine all the examples of a cover type are clumped together in one part of the plot, and then estimate the cover of that bundle. You can also build up by estimating the cover of each example of that cover type and adding them together. Can subtract, where instead of building, the opposite of building up, where we just subtract the areas that are not covered by a cover type. So this can be particularly useful if a cover type is really dominant in the plot. And then finally, using the visual aids, the reference squares, can help train our eyes and also assist in each of these strategies. So once you've estimated cover of those different functional groups, the cover types, we also want to identify cover of the dominant species. So we want to start out by identifying what is dominant in the plot. And although it's spindly, our Kentucky bluegrass, I think, is actually the most dominant species in the plot. And so we want to identify that species by name. If you can't identify the species, then take a picture of it and write down what you think it might be or some notes about it. And with that picture, again, use the dry erase board so that we know what plot it's from. And that way we can come back and try to identify it later. But do the best you can to identify it in the field. So here we're looking at Kentucky blue, and we want to figure out what the percent cover is. Now, it can be hard in this case because it's a very spindly species, but we do see it covering a lot of the plot. So now we're just looking at the green individuals, not the litter itself. And we'll note we're doing this in spring for the training video, but the sampling will be done in the middle of the summer, so the vegetation of this year's growth will be much more prominent when you're out doing your sampling. So thinking of our cover classes again, gonna think about, use my 10% as a reference and look at bundling the individuals. I'm thinking about clumping them in one area. And I think our cover is going to be in that second class. So I'm looking at about, when it's all grouped together, in that 10 to 15% range. So that'll be our second cover class. So again, identify the dominant species and identify the cover of that species. So once you've done that, you have your species richness, your cover by functional type, and your dominant species identified and its cover type estimated. You've completed vegetation sampling.